Hello everyone, I hope you all are having an amazing day. This is the part two of our machine learning project that is basically on a regression problem. And in this part two, what we will do, we will actually go through the exploratory data analysis project. In short form, it is called EDA. And in this process, what we will do, we will actually import the data, we will do data validation, and we will also do different sorts of data cleaning, and also we will do some different kinds of analysis like a univariate analysis, bivariate analysis for both the numerical variables and also the categorical variables. And finally, we will also do the outlier handling or outlier treatment to get the best output from our data. So let's begin. So at start, what we are doing is that we are importing our libraries. At first, we're importing pandas, and this is for the data manipulation and all other stuffs. We're using a NumPy to see the different kinds of values nicely. And for visualization purpose, we are importing matplotlib and seaborn. And for our machine learning processes that we will do in future, we imported different classes or functions from sklearn library. Okay. At first, we are actually reading in our Excel data. So the Excel data name is premium.xlsx, and it is actually in our working directory. So that is why what we can do, we can just use pd.read underscore Excel, and also we can use df.head3. So we can see the first three rows of our data. So if I run this, so now you can see different columns and their values. So the data is actually fairly cleaned at the moment because the expectation of from the data team to the project stakeholder was to get a cleaner data. Okay, so basically that's why the data is quite clean, but still there are some inconsistencies which we will have to go through and fix. At first, we can see that we have different kinds of demographic data like age, gender, region, marital status, number of dependents, BMI category, smoking status, all other things. Okay, but uh, but there are some issues. Okay, we will mention it after that. Now, if we use df.shape, we can see the number of rows and the number of columns we have in our data. So there are actually 50,000 rows and 13 columns in our data. And if we show you sorry, df dot columns, then you see the column names are actually they are like separated, like some are actually separated by underscore, but some are separated by space. So there are inconsistency in the column namings. Okay, like here is also, but it would be better if we get all the columns in the same naming convention. So for that, we will actually use snake case for the naming convention. So what it is, so this is basically what we will do. We will lowercase our column names, and also instead of using space, we will use the underscore. Okay, so all our column names will get consistent, and we can actually recall them very easily without any kinds of handling the spaces. Okay, so how we are actually doing it? So we are using str.replace function to replace the spaces with underscore. And also I mentioned earlier that we are going to lowercase the column names. So basically that is why we're also using str.lower function. And we are replacing the df.columns with the new df.columns. And now if we check our data, so you can see now everything got lowercase, and the spaces, instead of spaces, we are getting the underscores. Okay, so one thing is done. Now let's begin the real work. So at first we will check the number of missing values in our data. So for that, what we are using the df dot isNA function. So the isNA function actually returns the true or false values. Okay, and if we sum the true or false values, we will actually get all the true values, and we'll actually get all the like false values. So let's see what it shows. So here it shows for each variables how many missing values are there. So the true, so in the Boolean data value, the true means 1 and the false means 0. So when we are summing 1, we will actually get the actual values, but when we are summing 0, we will actually get 0. So here this 0 means that there are actually no missing values and all other things, but here are missing values like 11 missing values, and then 2 missing values for employment status, and 13 missing values for income level. So how do we want to handle these missing values? So let's actually do a calculation. That's basically 13. Okay, 13 divided by 50,000. That is the total row or we have in our data. So this is basically around 0.26. Let me just do 100. Yeah. So the percentage is 0.26 percentage of missing data in our whole data set. So what we can do, as the portion of missing values is very, very minuscule or very low, what we can do, we can actually remove the rows with missing values, and it will actually be the optimized thing to do, and it won't affect our data much. Okay, but suppose there are like 100 or like 300 missing values, then we might go towards the missing value imputation methods using mean or mode or median or all sorts of stuff. Okay, but at the moment, as we have very low missing values, if we remove all those missing values, we're actually good to go. So how we are actually removing those missing values? We are using df.drop na function, and we are using in place true. So it will, what it will do, it will automatically remove all the missing values from our data, and it will replace our data frame with the removed values. Okay, and we are checking the df again for the missing values. So now we can see that for each variables we are getting zeros. Okay, now let's check the duplicated, like how many duplicate rows we have in our data frame. So if we use the duplicated function and if we do the dot sum method, so it will actually show us the similar kind of result. So here we got the output as 0. So this means we do not have any kinds of duplicate rows in our data. Now let's check the summary of our data. Okay. So when we use df.describe, so it will automatically find out the numeric columns in our data, and then it will show the the 5-number summary for each numeric variables in our data. So what kind of variables we have numeric? So we have age values, we have a number of dependents, we have incomes in lakhs, and we also have the annual premium amount. Okay. So let's go one by one. So for age, we can see that average age is around 30.4, 34.5, and the maximum age is around 356. So this is actually a very suspicious value, that someone's age is around 356. Okay, so we will have to take care of this thing. And I think because of this value, our age variable is actually getting skewed. Okay, and in the number of dependents, so what is actually number of dependents? Okay, so dependence is actually the number of people. Okay, and the number of people cannot be minus. It will always be 0 or more than 0, or if I'm being in short, it should be positive value. But here we can see that the minimum, on the minimum, we see that number of dependents is -3. So there might be some kinds of issue while data inserting. So we'll have to take care of this. And incomes in lakhs, this sounds okay. Maximum value is 930 lakhs. This means around 9 crore. And the premium is also looking nice, pretty much nicely distributed from minimum to maximum. Okay, so at first let's take care of number of dependents. So let's take care of -3. So at first let's check that how many let's check like how many values are there that are less than 0. So what we will do, we will do the conditional indexing, and we will use the shape function. So now we can see that there are actually 72 rows where the number of dependents value is actually less than 0. This means the negative values. And let's check what are those negative values. So for that, we will use this technique. So at first we are using the conditional indexing, and then we are selecting and the specific column we want to see, and we're using unique to see the specific values. Okay. So of all the 72 rows, the values are actually -3 and -1. Okay. So here's the thing. When we see some kind of inconsistencies, we actually cannot delete those inconsistencies immediately. We will have to communicate with our the data team, okay, or with our stakeholder, or we actually cannot talk to a stakeholder directly. So for that, we can actually talk with our team lead, and he can actually talk with the project manager. Okay, so after clean and clear communication, we might get information on why these values are -3 or -1. So this might be the case that these are actually +3 and +1. So instead of +3 and +1, they got inserted as -3 and -1. Okay. So to solve this situation, what we will do, we will just take the positive values of all our negative values, and to do this, we can just absolute of our column and replace the column. Then we will actually get all the positive values. Okay. So now when we are checking that summary statistic of our numeric columns, we can see it is actually properly distributed. Okay. Now let's move on. Let's check the the box plot for all our numeric columns. Okay. Now, there is a one technique I want to show you all, that when we use df.info, we can check if there is any null values, or if the data types are actually accurately set or not. Okay. So now we can see the age is accurately set as integer, number of dependents is also integer, incomes in lakhs is also integer, and annual premium amount is also integer. Okay. And to get all the numeric columns in a their names, basically what we can do, the first technique we can do is that we can just manually write down the names of all the numeric columns. This is one thing. But another thing is that we can get the numeric column names by their data types. Okay. So what we can do, we can use this select underscore d types function, and inside this function, if we insert this argument, that is include equals to, and inside a list, if we provide the, what is it called, the data types like float 64 or integer 64, and then if we use dot columns, we will actually get all the columns that have these data types. Okay. So if I just run it in another code chunk, you can see it's returning me all the numeric columns. Okay. And now I can save this result in a separate variable, and then using this I can loop through this list using the df my data frame, and I can get all the box plot all together, and I won't have to run the box plot separately. So let me run this thing, and let me run this thing. Okay. So now you can see that I got all the box plot by just running one code chunk. I did not have to write four same codes for each box plot for each columns. Okay. So what is actually happening here? So I'm just using an iterator, like I named it as call, and it's iterating inside the numeric columns variable, so that this numeric columns actually has these values: age, number of dependents, income, and then annual premium amount. And when it is age, it will generate me a box plot. After that, it will be number of dependents, it will generate me another, and then another one, and then another one. So by that, looping through, we are getting 4 different box plot. But here's the thing, is that the convenience factor comes in here, is that if we can see the box plots side by side, then we won't have to, scroll up and down too much. Okay. So for that, what we can do is that we can use ChatGPT. Okay. So let me just copy this code. So here I am inside ChatGPT. Here I can just paste my initial code, and I can ask ChatGPT to generate me Python code such that I can see the charts or the box plots side by side. I want to see the box plots side by side, like two in each rows. Okay. And now ChatGPT will actually generate me the code chunk. So yeah, basically that's it. Now, if I copy this code and if I create another code chunk like here and paste it here. So yeah, this is how we can actually utilize ChatGPT for, for this kind of convenience factor or convenience stuff. So what we can see from the box plot is that age has several um, outlier values. Of course, age will have several outlier values because um, as you can see that there are many age values that are more than 100. Of course, these will be outliers. Number of dependents does not have any kind of outliers. Income in lakhs actually has outliers, but we will actually take care of it later. And annual premium amount has two outliers, but I think these are actually fine because the distribution for annual amount looks pretty okay, and there could be legit values of when the outlier is actually greater than 43,000 or around 45,000. Okay, so this could be legit. So we will have to utilize both our real life sense or real life scenario sense and also the technical sense. We'll have to match both of those together to decide if we can remove the values or if we will retain the values. Okay, we actually cannot just based on our technical knowledge, we actually cannot just remove all those things. We must have to include the domain knowledge or the real life sense here. So at first, let work with the age. So here, what I'm doing is that I'm actually checking the number of values in the age column that are greater than 100. So we can see that there are values like 224, 124, and these values are actually uh, appearing in our data that are greater than 100. So what we can do, so we are actually creating a separate data frame that is called df1, and in this data frame we are only containing those rows that have age less than 100. Okay, and we will also use the copy method. So we are using the copy method, so it creates a separate physical copy of our new data frame. And in the new data frame, we are only taking all the rows where age values are actually less than or equal to 100. And after that, if we see the distribution of our age column, we can see now the distribution actually looks much better compared to the previous one. Here we can see the average value is actually retains, but the five-number summary or the quartiles are actually properly distributed. Okay. Now let's do the income treatment. So we can see that there are lots of outlier values in the income, like 200, 400, 600, and 800 lakhs. Um, in a sense, a person's income can actually be more than 100 lakhs. So 100 lakhs is basically 1 crore. Okay, he might be some kind of minister, he can be some kind of a businessman, something like that. Okay, so this is actually when we're including our real life sense, this is actually possible. Okay, but yeah, for our analysis, we'll have to get in the technical knowledge in here to validate if it is possible or not. And we know that we can actually treat the outliers by using the IQR method. So IQR method is basically interquartile range method. And here what is interquartile range? Let's understand that first. So interquartile range is basically the difference between first quartile and then the third quartile. And then we have a specific formula that we will create two different bounds. Okay. And if a specific value is lower than our lower bound, and if it is greater than our upper bound, then we will consider that specific value as outliers. Okay. So how we will actually create the lower bound? So for the lower bound, the formula would be quartile 1, the value of quartile 1 minus 1.5 times 1.5 times the IQR value. Okay. And this 1.5 is actually kind of a fixed value. Okay. Like a constant value. And for the upper bound, we will consider the quartile 3 plus 1.5 times IQR. Okay. So we are creating a function here so that will calculate the lower bound and upper bound for the specific column. Okay. So here we're actually creating a function here. And in that function, what we did, we are actually including the income column here, and we will get our income columns, the lower bound and upper bound. And here we will actually will not consider the lower bound, that is minus 29, because income cannot be cannot go to, income cannot be a negative value. Income will always be 0 or greater than 0. Okay. So we will consider 67. So here, by using the IQR method, they are saying us that if a person's value is greater than 67 lakhs, we will have to consider them as an outlier. But this is coming from the technical aspect. Okay. But when we are considering the real life scenario, of course, a person's annual income can be more than 67 lakhs. He can be a very good businessman. He can be a very rich, like a multimillionaire or billionaire person. Okay. And his income could be much more higher than the 67 lakhs. Okay. So based on this 67 lakhs, or based on this IQR bound, we actually cannot, bound the whole thing, because we must have to be cautious when we are doing this kind of analysis, because if we do if we only consider the technical side of the thing, we might get, we might face the loss of data thing. Okay. So we need to validate that what are the values, okay, or what are the number of rows that are actually more than 67 lakhs. Okay, we'll have to find out this first. So here we can see that around 50,000 rows, that is our total rows, around 35 and 59, 3,559 values are actually greater than 67 lakhs. So of course, if we delete all the 3,559 rows, then we are actually deleting around 3,600 rows. If we do this, we will incur a massive data loss, and we cannot let this happen. So now what we can do, we can discuss this issue with our project manager or with our team lead, and by discussing in meeting, we can set a specific threshold by which we can actually do our analysis nicely. Okay. So after doing the meeting with the professionals, like our project manager and our team lead, we decided that we will only put all the values that are below 0.999 quantile. So this means around 99.9% values we were including. Okay. So let's see what are the income that has quantile 99.9%. So we get 100 lakhs. So this means around 1 crore. Okay. And now let's find out how many rows are there where the income is greater than 1 crore or 100 lakhs. So we can see that only 10 rows that have income values more than 100 lakhs. So 10 row is actually much safer to remove compared to around 300 and 600 rows. Okay. So what we will do, we will create another separate data frame, and we will only keep only keep the income values that are between 0 to 100 lakhs. Okay, so basically this is what we are doing here. Income lakhs less equal to one tile threshold. This is basically 100. And of course dot copy, because we're hitting another separate data frame. And now let's check the shape. So after removing all the missing values and also doing the outlier treatment, we have around 49,908 rows and 13 columns. Okay, so this is very good. Okay, now what we are doing here is that we are plotting histogram for each of our numeric values. Okay, and again I actually here we are actually doing the two side by side histogram plots, and I generated this code by using ChatGPT. Okay, and here what it is doing, it's just it just looping through all the access and all our numeric columns and providing the visualization for each columns. So now you can see is that the age is actually a right skewed, number of dependents, the frequency is actually quite okay throughout all the values. Incoming lakhs is also right skewed, and annual premium amount is also right skewed. Okay, so this is how our current distribution looks like. And let's check our current data, that is DF2. So this is actually our final data. So univariate analysis is actually means that we are analyzing each column separately. There is actually no effect of another column in that analysis. But now we will actually go through the bivariate analysis, where we actually get how each column behave with the impact of another column. Okay, so this is actually bivariate analysis. So at first let's check our numeric columns. We have these 4 numeric columns, and then we will actually plot scatter plot. Okay, scatter plot that will scatter plot of each independent variables versus our dependent variables. So the objective of our project is that we are predicting premium amount. So of course premium amount will be our dependent variable, and all other variables will be our independent variables. So here we are plotting scatter plot. So in the scatter plot, we can see that there is actually a upward relationship. Basically, when age increases, the premium amount also increases. Okay, but you can see that there can be it is very noticeable that there is a age group. Okay, so like for age group 18 to 25, the premium amount ranges between 300 and 500 to 3,500 to around 17,000. Okay, and then another age group, and then another age group. Okay, but when we're considering the full picture, we can say that when age is increasing, the premium amount is also increasing. And again, we do not want to run like each scatter plot separately. So what we are doing, we are looping through each columns, and we are plotting each scatter plot side by side. Okay, so here are the scatter plots. So income and the annual premium amount does not show any kind of pattern, and number of dependents versus annual premium amount is not showing any kind of pattern also. But age and annual premium amount has a distinct relationship with each other. Basically, they have a positive relationship, because when age is increasing, the annual premium amount is also increasing. Okay. Now let's do analysis of our categorical columns. And at first we will do again univariate analysis of our categorical columns. And at first what I want to do is that I want to check the number of unique values each categorical column has. And for that, what I'm doing, I'm creating a variable where I put all our categorical columns. Okay, so here what I did, I manually write down all our columns, but here also you can do the previous method, like you can use the select d types function to get all our categorical columns, but I used the manual method. And what I'm doing, I'm looping through this variable, and I'm generating the unique values each variable has. Okay. So here we can see that gender has two unique values that are male and female. Region has four unique values. Marital status has two unique values. That is perfect. BMI category has four unique categories. That is also perfect. But here's the problem. In the smoking status, we have no smoking, regular, occasional, but smoking goes to 0, does not smoke, and not smoking. So these additional um, values, we can actually map these additional values in no smoking, right? Because smoking equals to 0 means actually no smoking, and these two values also mean no smoking. So we'll have to figure this out. After that, we have employment status. It has unique values like salaried, self-employed, freelancer. So salaried means like he's actually employed. And then we have income levels, so less than 10 lakhs, 10 lakhs to 25 lakhs, and so on. Um, and we have medical history. So we have different kinds of medical history. And we have insurance plan, bronze, silver, and gold. So now let's do the mapping of smoking status. So here we are using the replace method, and we are using the dictionary method to replace the each values to the actual value. So here not smoking will be no smoking, does not smoking will also be no smoking, and smoking 0 will also be no smoking. And we are replacing it in our original data frame, that is df2 smoking status. And now if we check the unique method, then we can see only three values here: no smoking, regular, and occasional. So we actually figured this out. Now let's go with our univariate analysis. At first, we're checking the data. So it's fine. Now, what we are doing is that, so when we are actually doing the univariate analysis for categorical columns, we will actually see the frequency for the each category. Okay. And we can actually plot the frequency by using bar chart, or by using pie chart, or by using donut chart. So here the process is like that. What we will do, we will actually plot bar charts for all our categorical columns. But for that, we will have to go through a distinct steps. So by using value counts, we can actually see the actual frequency for each category. Okay. And if we put the argument normalize equals to true, then we will get the percentage. Okay. Percentage in 0.58, something, the values like that. And if we multiply it by 100, then we will get it on the percentage scale, like in 100% scale. So let me run it and see what we get. So here we get male value that is around 54.96%, and female is around 45.036%. And here name equals to proportion. So this means the value that are showing here, it is based on the percentage. Okay. And what we can do, we can just get this value in a variable, like save this in a variable, and using this variable, we can actually plot nice bar charts. So we save it as PCT count. So when we are using PCT count dot index, we will actually get the male and female. These are actually index. And when we're using PCT count dot values, then we'll actually get the actual values. Okay. So basically, we are feeding the index in X, and we are feeding the values in Y, and basically that's why we actually got a very nicely looking bar chart here. But again, we actually do not want to do this thing manually for each of our categorical columns, because we have 9 categorical columns, and if we do the copy paste method for each categorical column, so it's going to get very boring, and it's actually not an intuitive process to do. So again, for that, what we can do, we can actually loop through my categorical column variable where I have all my categorical columns saved. Okay, and I can show the bar plot side by side for each categorical columns. Okay, so let me run this. So now we can see the distribution of my each categorical columns side by side. So this is basically there are 9 columns, so 9 categorical columns. So this is basically like a 3 by 3 matrix. Okay, there are some inconsistencies, as you can see that the letters got checkered, but it's fine. For specifically for that, what you can do, you can separately create a bar plot and then see the result for yourself. So here we can see all the distributions. So unmerit and merit distribution is pretty much equal, and Northeast has like the least amount of people living in Northeast, and there are the least amount of people in my data set are suffering in obesity and all sorts of information. Okay, now let's move on to the bivariate analysis. Okay, before moving to the bivariate analysis, why we are actually doing this univariate analysis? So we are doing this univariate analysis to see at a glance if there is any kind of inconsistencies. Okay, so if there is any kind of another category, okay, that that was not supposed to be here. Okay, we can check on those kind of inconsistencies by plotting this kind of 3 by 3 bar chart or this kind of categorical columns, and we can see if there is inconsistencies at a glance. Now let's move toward the bivariate analysis. And again, when we are doing bivariate analysis, we will actually include 2 different categorical columns, and we will see how one variable affect another variable. So here, when we are talking about bivariate analysis of our categorical columns, we must have to consider cross tabulation. And in Python, cross tabulation is very easy to do. We just have to use pd.crosstab and then provide the column names here. Okay, and we can also we can also visualize the cross tabulation by using side by side bar chart. So for that, what we'll have to do, we will have to save the cross tabulation result in a variable, and then if we just use crosstab.plot kind equals to bar, then it will automatically show us the side by side bar chart for each categories. Okay, and what is the value? Of course, the value will be frequency or count of each category. So let's see. So from this print cross tab, we actually got the actual numeric values. So this is basically when insurance plan is bronze and the income level is around 10 lakhs to 25 lakhs, there are 5,307 people. Okay, and when the insurance plan is gold but the income level is less than 10 lakhs, there are 931 people. Okay, so this kind of information we can get from the cross tab. And similarly, we can visualize this result in bar chart. And another thing is that we can also visualize this thing by using heat map also. Okay, so the same thing. The same thing we can visualize using heat map. And another thing with the heat map is that initially, if you run without this fmt argument, you will get the values like this. Okay, it's like scientific value. And if you do not want the scientific value, if you want like to show exact values, you will have to use this argument fmt equals to d. Then you will get like actual values, right? So this was our exploratory data analysis process. And from this exploratory data analysis process, we are actually now able to know about our data a bit more than our initial stage. So we know what kind of variables we have in our data set, how the age variable is distributed, how our premium amount is distributed, how the incomes are distributed. And furthermore, we actually did not get to know about our data. We actually cleaned our data. Okay, we actually cleaned our data. We removed all our missing values. We also handled the outliers values and many things. And we generated a different kinds of visualization that will actually help to make a decision on what kind of machine learning algorithm we will implement in our data. So thank you very much for staying with me, and let's see what we do in our next part. Thank you very much.